All right, this is 9.2 part 2. I'm going to go over just a couple examples here um, to kind of introduce a little bit more in depth on these polar equations and graphing. So on your notes, this first example that you have is r equals 4 cosine theta. And I really wish that we were in the classroom to do this together, because there's a lot of connections that we're going to make to trig graphing that hopefully this video will somewhat make clear also. Alright, so for yesterday's lesson, you had something very similar to do. I gave you a table very similar to this one that you see here on the screen. And all you have to do is, for now, all of these theta values, you're going to plug into the equation for theta and then work it out. So for instance, if theta is equal to 0, we plug in 0 in for theta, and you get r equals 4. Right? Here for, oh, the 4 popped up. Okay, so for pi over 6, you plug that in again for theta, so it's really 4 times cosine of pi over 6. And we know cosine of pi over 6, that's root 3 over 2, and then times 4. And using decimals, actually, that comes out to 3.46. Alright, for pi over 4, that comes out to, these are getting annoying, for pi over 4, that comes out to 2.83. For pi over 3, you get 2. For pi over 2, you get 0. Right? I'm going to pause here, and if you look at these values, we started with 4, and they're decreasing to 0. Okay, I want you to keep that in mind. And I'm going to pause real quick. Well, I'm going to pause and fill in the rest of these values, but I'm going to come back to the 4 to 0 in a second. Okay, so here you can see I put in the values, and I color coordinated them for a reason. You'll see in a little bit. Okay, but here are all these values, and if you notice, they all repeat in some sense, right? They just change signs here and there. Okay, but these are polar coordinates, right? We know that from 9.1, these are in the form of r comma theta. Okay, so look at this first point right here. Oops. You've got you have 0, you have 4 comma 0, right? So at angle 0, we go 4 rings out. 1, 2, 3, 4. Okay. Then the next point is r comma theta, so 3.46 comma pi 6. So at pi 6, you go just under 3.5 rings out, right? 1, 2, 3, and maybe something like that. Okay, so then you do the same for these other ones at pi fourths, right? We know this is pi fourths, this is going to be pi thirds, and this is going to be pi halves. Alright, and you plot these points at pi fourths, it's 2.83. Okay, so 1, 2, just under 3 rings. There's going to be some human error here. At pi third, at pi halves, oh, I'm sorry, we're in the wrong spot. At pi fourths is 2.83. At pi thirds, it's at 2. And then at pi halves, it's at 0. Okay, so what you can see is that from where we started, right, it went in this path right here, like that. Okay, these keep popping up. Right, now at 2 pi thirds, okay, what happens at 2 pi thirds? Now remember when we were graphing that, right, at 2 pi thirds, it says -2, so we're going to go the opposite way into quadrant 4. So it's right here. And you know what? I'm going to make that red because I was supposed to color coordinate that. Make that red. Okay? Alright, and then at 3 pi fourths, it's -2.83. Alright, -2.83. So we're going backwards. 2. Right, so it's like this. At 5 pi 6, it's -3.46. 2, 3. And then at pi, okay, so at pi, which is right here, right, it says -4, so we actually go in the opposite direction, and we're right over here, back where we started, right? Now, when we get back to where we started, we're done, okay? When we get back to where we started, we're done. That's going to be key for the next example, all right? And so this actually is supposed to be a circle, all right? I know it's a little hard to tell. We have this polar grid behind it, and you know, obviously it's not a perfect circle, but it actually is a circle, all right? The center of the circle is at 2, 0, and the radius is 2 units, all right? And so that's what we're working with here, okay? Now, I mentioned that we're going to do, it connects to trig graphing, all right? Let me do this real quick. I'm going to do this over here. So let's suppose it's y equals 4 cosine theta, all right? And I'm going to remind you of some key components of trig graphing, right? Remember we talked about the amplitude, right? That's 4 in this case. There is no vertical shift because there's no d value. For phase shift, it's -c over b, and in this case, it's 0 over 1, which is just 0, all right? And then, oops, the period, right? Remember we talked about the period. That's 2 pi over b, but b in this case is 1, so our period is 2 pi. All right. Now when we graph, let me also do this. When we graph this, I'm sorry for these blue dots here. I wish they would go away. Okay. I'm going to show you what the graph looks like here. All right. So if you look at the trig graph that I gave you right here, right? If you follow along, so it starts. Remember when we draw a cosine graph at 0, we start at the peak. So it's at 0, 4. Now, the 0 is the angle, 4 is your quote-unquote R value. This point right here is actually over here, right? Okay, I want you to make that connection. And then look, you see how on the trig graph, remember I talked about it's at 4 and these values are getting closer to 0? That's what's going on at the table here, right? We start at 4 and it's decreasing to 0 because it's going down to 0. Well, it's going down to 0, right? Because these also represent, these values are smaller than 4 because these are your R values in the polar grid. Okay. So 4, we start at 4, 4 rings out. But as we get closer to 0, the distance of these rings are getting smaller and smaller to 0. Right? And so what happens at pi halves? On the trig graph, at pi halves, the x-intercept is at 0. So here at pi halves, we have 0. Right? And then what happens after pi halves? It dips down. Now these are negative values. Which made sense because, remember, as these angles are getting bigger, right, after pi halves, it's 2 pi thirds, and then 3 pi fourths, etc., right? But since these are negative values, that's why we want the opposite way, right? And so that's why the circle goes this way, and round it goes. So for the trig graph, you're going to have this continuous cosine motion, right? But that also translates to the polar graph. It just goes in a circle like this. Right? So that's the connection we're trying to make here. Okay. Take a look at the second video. I'm going to go over the second example as well.